All right, here is a quick video or short video on density. And density, as you're hopefully aware, you've hopefully seen density before in a science class. It's defined as the ratio of an object's mass to its volume. It's a very simple formula: density equals mass over volume. So if we want to know the density of an object, we just need two types of measurements. We need a mass and a volume of some sort. And density is referred to as an intensive property in the sense that density does not change depending on how much you have of it. Whether you have a pound of, let's say, gold or a kilogram of gold, the density is always the same on a pure substance. And because of that, density can often be used to identify a pure substance. Most objects' density, or most materials' densities, have been studied, tabulated, and what have you. Typical units of density, right, they're going to have a unit of mass over a unit of volume. So you might see grams per milliliter, for grams per liter, grams per cubic centimeter. Even in our country, maybe pounds per cubic inch, right? It's always going to be a mass unit over a volume unit. Or maybe pounds per gallon, or quart, or, again, it just has to be some mass, ounces per quart or ounces per cup. Those are all valid units of density. So, let's say you find a shiny piece of metal that you think is aluminum. In the lab, if you want to determine it was aluminum, you would probably want to find two measurements of your object, the mass and the volume. So they have measured the volume to be 245 cubic centimeters and then weighed it and found it weighed 612 grams. So if you want to find the density of this material, the formula is fairly straightforward. 612 grams divided by 245 cubic centimeters. Your calculator, remember, is always just going to give you a whole bunch of values. It is up to you to apply the significant figure rules. This measurement has 3. That measurement has 3. You're doing division, so you have to go to the least number of significant figures, which are 3. So counting from the left, 1, 2, 3, that's the 9. This is 7. So this is going to get bumped up to a 0. This is going to get bumped up to a 5. So this would be reported as 2.50 grams per cubic centimeter is the density of this material. And if you wanted to see if this was actually aluminum, then you'd look up what the given value or the accepted value for the density of aluminum is in a textbook or online or somewhere. And this is a little bit high for the density of aluminum. I believe aluminum's density is less than this. So, but that's one usage of using an object's density. Here's our second example. What's the volume of a liquid that has a mass of 30.6 grams and a density of 0.585 grams per milliliter? Remember, this time we're solving for volume. We want to figure out what volume this mass of this material would occupy. So we've got a mass and our density. So if density is mass over volume, you are more than welcome, if you are more comfortable just plugging in numbers and then solving for what's missing, you're more than welcome to put the density in here, the mass up here, and you're trying to solve for this V on the bottom. In my work, I will always rearrange things algebraically to get what we're solving for isolated on a side by itself. So hopefully you can understand, if you want to get volume by itself, hopefully you understand that I would need to multiply both sides by the volume. So I will get this. And then lastly, to get volume by itself, I need to divide both sides by density. So I end up, after my manipulation of my thing, I get expression volume is mass over density, and that's 30.6 grams over 5.85 grams per milliliter. This value has 3 significant figures, so does this. So when I divide them, I get 3 significant figures, which is 52.3. And remember, you don't want to be looking at the problem statement for the unit. You want to look at your work. And you've got grams, and then grams over milliliters down here. Hopefully you can see that the grams goes away. When the grams are left, if I'm looking at just what units are remaining, I've got 1 over milliliters. Because the grams that were present on top and bottom have canceled out, leaving just 1. And this right here is just a complicated way of writing milliliters. Just like in math class, and you can test this out, 1 over x is just a complicated way of writing x.